Hello everybody, welcome to my channel. This is a new video tutorial series on my GameLeaf with Blueprint plugin. In this video tutorial series, I will teach you how GameLeaf works and how to use my GameLeaf with Blueprint plugin. In the very beginning of this video tutorial series, let's begin with some basic concepts. First, let's talk about two basic concepts in computer network, IP address and port. You can imagine that the PC is a large housing unit. Processors are families living inside rooms of the unit. The unit has its address and each family has their room number. The IP address corresponds to the unit address and the port corresponds to the room number. Anyone in the unit or outside of the unit can send a mail to a family in the unit. Two different units won't have the same address because if they did, the delivery won't know which building to go to. So, two different PC can't use the same IP address. Same reason, two families in the unit can't share a same room number too. So, any two processors can buy with the same port. There are two types of ports that we need to concern when we use GameLeaf, UDP and TCP. This is a more advanced concept. We may discuss it in the future. We only need to remember that there is UDP and TCP, two types of ports that we need to concern when we use GameLeaf. Processors either on the same PC or on a different PC can communicate with the other processor via the IP address and its port. Now, let's see how Unreal Dedicated Server works. In source code version Unreal Engine, we can add server targeted in CPP project source folder to enable Unreal Dedicated Server feature. Then, we can build a dedicated server package using the project launcher inside of our Unreal editor. After that, we can run the server executable in the dedicated server package to start a dedicated server process on a PC. To communicate with your game client, the dedicated server process will open a port on the PC. The game client in the PC or another PC can connect to the dedicated server process via the port the dedicated server process opened. Once the client connects to a same dedicated server process, they will be in the same game, same map, with the same game mode. If the dedicated server process changed its map by server travel, all clients connected to it will be brought to the new map too. You can open multiple dedicated server processes on the same PC. Because of any two processors can't build with the same port, the Unreal Dedicated Server process will check if the port is going to use is binded by another process. If so, it will increase the port number by 1. The port which the Unreal Dedicated Server process opens by default is UDP port 7777. So, if you open two Unreal Dedicated Server processes, they will use 7777 and 7778 port. Now, let's talk about GameLeaf. You may have already noticed that you can open multiple Unreal Dedicated Server processes. The maximum number of Unreal Dedicated Server processes your PC can open is limited by your PC's performance. When your player number increases, you need to buy new PCs to host your game. Or when it decreases, you need to sell the spare PCs for extra money. It doesn't make sense to attempt to handle all of this yourself. That's why we need to use GameLeaf servers. First, we need to know some concepts of GameLeaf servers. The first one is Virtual PC. People normally call it VPC as an abbreviation. I will call it VPC in this video tutorial as well. A VPC is similar with your PC but virtual. You will see the use of VPCs in many server hosting, renting service provider. You can create a VPC or terminate a VPC easily and choose which kind of performance you need. Generally, you can choose how many cores CPU you like, which CPU brand and architecture you want, as well as how much memory and storage you need, and how fast network you want. Normally, server hosting or renting service provider will charge you based on number of VPCs times how long you used them and which type VPC you are using. GameLeaf will charge you in the same way too. VPC is similar with your PC. It has performance limitation. Even if you select a Monster class VPC, which is like 96 cores, 768 GB RAM, 25 gigabits per second network, there is a limitation. You will need to increase your VPC's number to host more dedicated game server processes. The group of VPCs will make up your fleet within GameLift. Each VPC within a fleet is called a fleet instance. Now, we have the VPCs running in a GameLift fleet and Unreal dedicated server processes running in the VPCs. But with GameLift servers only, clients don't know where the VPCs are. And because of the fleet keep creating new VPCs and terminating old VPCs, the IP address will be constantly changing. So, we need a method that works as a dictionary to tell clients where is the VPC, which port you should connect to, and which Unreal dedicated server process you will connect to. This dictionary is the GameLift service. GameLift service will always be there once the GameLift fleet is created. It has constant IP address because it won't be recreated or terminated as long as the fleet is running. Each Unreal dedicated server process start will need to tell GameLift service which port it's using, which log file it will output its log to, and is the process ready to serve. That's why we need to call init SDK, construct process parameter, and process ready at the start of our game server process in Unreal 4 project. And after that, GameLift service will add the Unreal dedicated server process into its dictionary and keep asking every process in the dictionary periodically if it's still healthy and running by triggering the health check function inside the process parameter. If a process can't reply health check on time, GameLift service will terminate it automatically. After the Unreal dedicated server process is ready, it will wait until a client applies for a game session. Game session is a session between GameLift service and Unreal dedicated server process. It will help GameLift service managing its resource and handle auto-scoring. If there is no client creating game session, the Unreal dedicated server process will sit in the VPC forever. Once there is a client apply for a new game session, GameLift service will try to find an Unreal dedicated server process which is ready, healthy, and not associated with another game session. If there is a result, GameLift service will notify the Unreal dedicated server process by calling the start game session event in the process parameter. And the Unreal dedicated server process need to activate the game session before timeout. Then the GameLift service will mark the Unreal dedicated server process associated with the game session. If there is no result, GameLift service will return no available process error. After the game session is active, GameLift service will return the game session and its associated Unreal dedicated server process IP address and port. Then, the client will be able to connect to the Unreal dedicated server process and create player session on the game session. Player session is a session between GameLift service and the client. It will help GameLift service managing its resource and handle auto-scoring. When the game ends, the Unreal dedicated server process need to call process ending to tell GameLift service this dedicated server process will end, and Unreal dedicated server process need to call create server to terminate the dedicated server process in 5 minutes. Once the Unreal dedicated server process is terminated, GameLift service will start a new Unreal dedicated server process to replace it. New loop again. If an Unreal dedicated server process create without calling process ending, there will be a process exit without calling process ending error, and GameLift service will mark it as crashed. We know that you can open multiple Unreal dedicated server processes in a VPC, and you can create many VPCs in a GameLift fleet. But we don't want to create VPC manually when the player number increases in the middle of the night, or hire a server manager to monitor the player number and open or terminate VPCs. So, we need auto-scoring. At the beginning, the fleet will only have a fleet instance filling with Unreal dedicated server processes. While players are playing the game, these Unreal dedicated server processes will be associated to a game session. And now, let's say a client applies for a new game session, but all Unreal dedicated server processes in GameLift service are already associated to a game session. There is no available process left. So, GameLift service will return a no available process error to the client. To solve this problem, we will set up auto-scoring. When there are less than 50% or 30%, etc., Unreal dedicated server process not associated to a game session, create a new VPC in the fleet. Because power up a VPC will take some time, we always need to set a larger percentage to make sure the VPC will be on before available Unreal dedicated server processes run out, or no available process error will be returned to some clients. The number of VPCs in the fleet will keep increasing during the player number increasing. But when the player number is dropping, we need to power off unused VPCs to make sure our money won't be wasted on unused resources. So, auto-scoring will handle scroll down logic for us too, but it's not comfortable. When there is more than one VPC, that all Unreal dedicated server processes in it are all not associated to a game session. Auto-scoring will turn it off. When GameLeaf service is going to turn off a VPC, it will trigger process terminate event in process parameter. We need to call quit server to quit the Unreal dedicated server process in 5 minutes, or an error will be occur and the free state will turn to interrupt and no longer function. Now, let's talk about GameLeaf local. When we finish building a dedicated server package from Unreal Editor, we want to test it, but upload it to GameLeaf, creating a fleet, and waiting until it's active will take about 30 minutes. We need a faster way to test it. So, we need to use GameLeaf Local. GameLeaf Local is a program that is used to simulate GameLeaf service on our computer, but it works differently. In GameLeaf Local, the first few steps are the same. Unreal dedicated server process will tell GameLeaf Local which port it's using, which log file it will output its log to, and is the process ready to serve. Then, GameLeaf Local will keep asking Unreal dedicated server process if they are healthy or not. When the client wants to request a new game session, because we run Unreal dedicated server process on our own computer, there is no fleet ID. We need to use a dummy fleet ID. Then, GameLeaf Local will tell Unreal dedicated server process its fleet ID and game session ID, and the Unreal dedicated server process will activate it. Both fleet ID and game session ID will be associated with the Unreal dedicated server process. It will be the only game session in the fleet, and the IP address returned with game session will always be 127.0.0.1. You can create multiple Unreal dedicated server process on the same PC. But if another client applies for a game session with the same fleet ID, GameLeaf Local will return no available process error, because the fleet ID and the game session are both associated to the previous Unreal dedicated server process. So, the new client needs to apply for a new game session with a different fleet ID to get the game session. And moreover, if the client wants to search a game session, it can only use describe game session instead of such game session with its fleet ID, because such game session is not implemented into GameLeaf Local. The last thing, let's talk about security. In Unreal Engine, it's quite different between what we often hear. Let's talk about two concepts first: client-server separation and client-server combination. Most small companies like to use two projects to develop their project, one for client and one for server. The code is separated into client part and the server part. So, as long as their employees don't treat them, they will connect the resource service to server only. This is client-server separation design module. There are many benefits of client-server separation module. Two groups of people can continue their work asynchronously, and it's easy to design a harder to hack system because the server always have a lower risk level. However, Unreal is client-server combination module. You may have noticed that there is no separate project for server. You use the same project to build client and server, and they communicate with each other with RPC system. It's client-server combination module. It has many advantages too. Developers can develop client and server together, and it's easy to make sure client-side and server-side's code quality are at the same level. Client-side and server-side will have similar mean time between failure. So, most of big projects will choose client-server combination module. When we talk about client-server combination, we need to consider that the server side will have the same risk level as client, which is high. So, for data that is generated by a client, there's no need to send it to a server, then upload it to a resource service. We need to divide the data generated from your game and the data you need to get from resource service by risk level. For example, character customization will be low risk, so you can get the data from a client directly, no need to go through any additional server. When we need to handle data that should be treated securely, we need to generate it in the server or get it by the server and use a method to mark the data from the server as from server. For example, we can use a script to add the server's IP to an IP set in the server and go through a web application firewall and app sync web API. We need to consider that the client also can send a request too. The sender shouldn't be trusted. So, all requests the server send need to go through a web application firewall, then the app sync web API. The web application firewall will check if the source IP of the sender matches any IP in the IP set you set up, then pass the request to web API or drop it. The web API will get the resource for the server. If a client or hacker try to get the data, web application firewall will block it. It's what I used in an earlier video tutorial. Somebody may ask, how about using an RPC function to send the request from the client to server, then make the server send the request? First of all, it's not a shortened route. Second, if you send the package to the server, then a cheater tool can create a fake package and send it to the server too. In Unreal Engine, RPC function will send data through UDP port without any other security steps. RPC functions should be considered as the most risky part in the whole system. There are many other things that we need to consider when we design a server system. For example, if the database we are using is MySQL or Redis or any other database that only support connect with long-term socket connection, then the request should always go through a server. That's why we can always hear that we should use server to connect database. But AWS RDS and DynamoDB is using short-term HTTP-based web API. There is no need to consider this reason. AWS RDS is already a server that helps you handle the connection between MySQL server. So we need to use the shortest route to transfer the data. The longer the route is, more risky it will be. That's all. Thank you for your watching.